Hello, awesome Algebra 1 students, and welcome back. Our final video on solving systems of equations will be with the elimination method. There are 3 steps in the elimination method. In the elimination method, you have to first identify either equal terms or opposite terms. Equal meaning exactly the same, and opposite meaning same digits, but one is positive and one is negative. So equal would be something like 4 and 4. Opposite would be something like 4 and negative 4. Equal would be something like -5 and -5. Opposite would be -5 and +5. Now, if you have equal terms, the way that you eliminate one of the variables is by subtracting the equations, because that's how you create a 0 term, as you'll see in our examples. If you have opposite terms, you would add the equations to create a 0 term. After that, you solve and you check your solution. So let's take a look at some examples in a worksheet practice and then also using IXL. Okay, so when you are talking about elimination, elimination means to create a 0 term. So there's 2 ways to create a 0 term. You can either create it with subtraction or you can create it with addition. Now, 0 terms eliminate a term completely because 0 times anything is itself. So the way I can tell I'm going to use elimination in this example is that my equation has all of its like terms stacked on top of itself. The x is on top of the x, the y is on top of the y, and the numbers are on top of the numbers, and the equation signs, your equal signs is on top of the equal signs. So I'm looking for either equal terms or opposite terms. So does 4x equal -x? No. Does -6y equal 6y? No. Now let's look for opposite terms. Is 4 opposite -1? No. Is -6 opposite 6? Yes. So these are our opposite terms. Now, how do you make 0 out of -6 and +6? To make the 0 term out of opposites, you would add them. So in other words, -6y plus 6y is how you end up with 0. When you create 0, you end up eliminating that variable altogether. So because these are opposite terms, we're going to add these equations. So I'm adding everything straight down, and I like to put in my addition symbols all the way through. I'm just going to add up all the like terms, and I'm going to keep my equal signs separate. So 4x plus a -1x, that is a 3x, okay? -6y plus 6y, we already talked about it. That is a 0 term, equal sign on the line. -10 plus -2 is -12. Now that we have eliminated our y's by creating a 0 term, we can solve for x. To solve, we divide both sides by 3. That's a big 1 factor. And we end up with x equals -4. Remember, our final goal here is to have a solution. And a solution contains an x and a y. So we just found that x is -4. Is that enough? No, I'm going to get rid of some of this so that I can go back here and realize I need to go find my y. How do you find the y if you've already found x? Well, the easiest way to do that is by substitution, which again, if you watch the other video, you're pretty familiar with. So we're going to take this x equals -4 and we're going to substitute it into one of these 2 equations. Looking at this, it looks like you deal with slightly larger numbers in the first equation, so I'm going to substitute this in the second equation. Here we go. Remember, this is a hidden -1, so when I go to substitute, that's -1 times -4, because I'm substituting for x, plus 6y equals -2. That would be 4 plus 6y equals -2. Subtract 4 on both sides to create a 0 term, and you get 6y equals -6. Divide both sides by 6, that creates a big 1 factor, and you get y is -1. So our final answer, we have -4 for x, -1 for y. I always suggest checking your answers. Let's just do a quick mental check. 4 times -4 is -16. -6 times -1 is +6. Does that equal -10? Yes, it does. And then again, we already used the second equation to find the solution, so it should work. -1 times -4 is 4. 6 times -1 is -6. Does that equal -2? Yes, it does. So I did my checks very quickly to keep this video short. I suggest always taking the time to check. All right, let's take a look at our second one here. Again, we're trying to create a 0 term. And to do that, we need either equal terms or opposite terms. Are my x's on top of x's, y's on top of y's, equal sign, constant, constant? Yes. So here we go. Do we see equal terms, meaning the exact same thing? I see an x over an x. Are those exactly equal? Yes. So because we have exact terms, how do I make a 0 out of an x and an x? What am I going to do with those? Would I add them? No, that doesn't make any sense, right? I would subtract them. So because I'm going to subtract to make 0, I'm going to subtract all the terms in this expression. Subtract, subtract, subtract. So here we go. X minus x is 0. -4 minus positive 5y, oops, I forgot to put my line in, is -9y. And -4 minus 5 is -9. Now we can go ahead and divide to solve for y. That creates a big 1 factor, and y is 1. So in our solution here of x and y, we now know that y is 1. I feel like that was unnecessary. 1. Okay, now we need to substitute. I'm going to clear some of this up so I can go back and see what my original equations were. But we need to substitute to find x. So I know again that y is, to find x. So I know that y is 1. This is y and y is 1. I need to find x. So which of these two looks like the easier one to solve? I don't know. This one has a negative in it. So maybe I'm going to substitute into the bottom one. It doesn't matter. You could substitute into either one. I'm just trying to think of which one is a little bit easier. So now I'm solving for x. I'm plugging in 1 for y. So 5 times 1 is 5. So x plus 5 equals 5. Subtract 5 from both sides. That makes a 0 term. And x equals 5 minus 5 is 0. So I know the x value of my solution is 0. Let's do a quick check. Does 0 minus 4 equal -4? Yes, it does. And does 0 plus 5 equal 5? Yes, it does. So I feel very confident that this is the correct answer. All right, let's go ahead and look at some examples now from IXL. Okay, we are using the code 2CN here. And again, we're solving using elimination, which means we're looking for equal terms or opposite terms. So here we go. The first thing that stands out to me is that we have a 7x on top of a 7x, which leads me to believe that to create 0, I would subtract. So I'm going to write it out here so that I can actually have room to do this math, because otherwise it's a little bit crammed. And if you're doing this on a piece of paper, you're going to have to write it out anyway. So I know I'm going to subtract all of these terms because 7x minus 7x is how you create a 0 term. So 7x minus 7x, 0 terms. 7y minus 6y is 1y. 7 minus 15 is 8. And -8. Guess what? 1y is the same thing as just y. So now we know that y is -8. What a lot of students like about substitution is that it can give you your one of your variables very quickly. So I now know that the value of y is -8. Be careful not to put that where the value of x goes. How do I find the value of x? Well, I'm going to take this information here, this -8 for y, and I'm going to substitute it into one of these equations. The only thing I notice is that this has a 15 and this only has a 7. So I don't know, maybe the first one's going to be easier. Who knows? We'll just try it anyway. Okay, so 7x plus 7 times -8 equals 7. 7 times -8 is -56. Add 56 to both sides. 56 to both sides, make a 0 term. So 7x equals 7 plus 56 is 63. Yeah, I believe that. Divide both sides by 7. This creates a big 1 factor. X equals 9. Okay, so over here, we're going to come back to our answer. We know that x is 9 and y is -8. And in IXL, what's nice is that you don't necessarily have to check. They'll do that for you. And we were correct. Huzzah, wonderful. Okay, example number 2. First thing that stands out to me is that we have a, is that we have a positive 5y and a positive 5y. Again, these are equal terms, which means we're going to subtract. Okay, so I have 3x plus 5y equals -13. And in my second equation, -x plus 5y equals 11. I already know I'm going to subtract because that's how I create a zero term. And here we go. 3x, now here's the tough part, 3x minus negative x. Subtracting a negative is equivalent to adding. Remember that. So really, this is equivalent to 3x plus x, which is a grand total of 4x. That's a tough one. 5y minus 5y is 0. That's good. Equal sign on the line. Negative 13 minus 11 is negative 24. Divide both sides by 4. That creates a big one factor, and x equals negative 6. So over here in our solution, we're going to make sure that we put it with x is negative 6. Now we have to go find y. All right, so we know that x is negative 6. Shoop. So which of these equations would you rather plug it into? Looks like this has a pretty simple coefficient, right? Just negative 1, so I'm going to plug it into the second equation. Negative 1 times negative 6 plus 5y equals 11. So 6 plus 5y is 11. Subtract 6 from both sides. 5y, oops, that's a zero term, equals 5. Divide by 5 on both sides. It's a big one factor. You get y equals 1. All right, let's see if that's correct. Clear all my drawings, and voila, we good. All right, this is another example with equal terms. So we're going to go ahead and skip here. A little too far. Let's try to find one with opposite terms. For some reason, it doesn't want to give me one with opposite terms. Okay, what we will do then is we'll go ahead and look at this one, which is a little bit more of a challenge one anyway. So for this one, we have here, you'll notice that the x's are on top of the x's, the y's on top of the y's, the 11 on top of the 11. Now, even though the 11s are equal terms, that's not going to help us eliminate a variable. So notice that 9 is not equal to 1 and negative 2 is not equal to 1. We don't have equal terms or opposite terms here. So when that happens, you get to pick a variable that you want to eliminate. So I'm going to eliminate y. That's going to be my choice. Now to do that, if only I could make this bottom term a 2y. If that was a 2y, these would be opposites and I could add. Well, how do you do that? You just multiply the entire equation by 2. So here's what it ends up looking like. Your top equation is not going to change. You're still going to have 9x minus 2y equals 11. But your bottom equation becomes 2x plus 2y equals 22, because all I did was I multiplied each of these terms by 2. What does that do? Well, that gives us opposite terms. In opposite terms, to create 0, we're going to go in and add. So we're going to add all of our like terms here. Okay, so now we're going to add 9x plus 2x is 11x. Negative 2y plus positive 2y is 0. 11 plus 22 is 33. Divide both sides by 11 because that's a big one factor, and you get x equals 3. So now I know that x equals 3. Now, when you are substituting back in, always use your original equations. Unless you are 100% positive that you did the math correctly, you want to avoid using any type of equation that you created. So I'm going to take x equals 3 and I'm going to substitute it into the second equation because it's less messy. So here we go. 3 plus y equals 11. Subtract 3 on both sides. Y equals 8. Wow, that was quick. I didn't expect that. And let's see if we got that right. Yes, we did. Okay, we're going to do another example of where you have to multiply to create a zero term or big one factor, and then this will be our last one. So here again, we have a negative 10x over a negative 5x, a negative 2y over a negative 3y. None of these are equal terms or opposite terms. So the way I see it is if I'm going to eliminate y, I would have to change both of these into the same number. So that would require multiplying both equations because I can't change 2 into 3 and I can't change 3 into 2. I could change them both into 6, but I like to do a little bit less work. So I look at this as I can change a 5 into a 10. Better yet, I can change a negative 5 into a positive 10x. That would allow me to add because adding is usually easier. So I'm going to multiply this second equation by -2. Here's what ends up happening. And this is not something you have to do, but it's something that just most students end up choosing to do. My first equation doesn't change. -10x minus 2y equals -6. But my second equation becomes positive 10x plus 6y equals positive 38. And notice that all of these negatives became positives because I chose to multiply by -2. Now, if I hadn't done that, if I had multiplied by +2, I would still have equal terms and I could still eliminate, but now you got to deal with negatives and ain't nobody want that. So I have opposite terms, which means I'm going to add. So I'm going to add all the way across here, add, and here we go. -10x plus 10x is a 0 term. -2y plus 6y is 4y. And -6 plus 38, let's see, 38 minus 6 is 32. Divide by 4, that creates a big one factor, and y equals 8. Look at that. I didn't have to deal with negatives. I could just do some pretty simple math. Now we need to find x. Okay, let's find our x. So I know that y is 8. I go back to my original set of equations. Ooh, which one looks easier? I don't really want to deal with this -19 anymore, so I'm going to go ahead and substitute that into the first equation. That's just what I feel like. -10x minus 2 times 8 is -6. 2 times 8 is 16, so that's -10x minus 16 is -6. What did I just do? -6. Add 16 to both sides to create a 0 term. -10x equals 10. Divide both sides by -10 to create a big one factor, and x is -1. Let's see how we did. -1. Clear my drawings, and voila, we got it. Okay, so stop share. There we go. All right, so that wraps up today's video on solving equations, systems of equations using elimination. You must have either equal terms or opposite terms to either subtract or add. If you're not given those right away, you can always multiply one or both of the equations to create them. That's it for today. Have fun eliminating.